Hi, welcome back. Today we are going to plug all the components together and we are going to design the optimization system for the routing problem. So let's start by creating, as usual, our routing agent. And we put the routing agent into the decision network. Now we double click on the agent and we open up the event graph designer. So as we already seen in previous videos, we can start by adding some events, in this case a pre-simulation and post-simulation. So we are going to use these two events in this way. We're going to use here the pre-simulation event to set up all the components of the agent. In particular, we have the location and fleet that will be used by the optimization system to optimize the deliveries and the route, and then we're going to use the post-simulation event to print out the results. So let's go ahead and let's just add some set component semantics. In previous videos we saw how to set up the locations and fleet with for example a simple map interface where you can click on locations. In this case instead we're going to use JSON input format. So we're going to set up the locations and the fleets. So I'm going to add two set component semantic blocks and we wire them up in this way. So when the pre-simulation event triggers, it's going to run first this block and then this block here. So let's set our targets, fleet component in this case, and then location component here. And in the input socket here, we're going to create two variables now, one for the fleet and one for the location. So let's call it fleet, for example, and connect it to the struct value input socket, and then we can create a location variable, such like so. All right. So as you see, we can click on the fleet variable and we can select the struct. So you see that this input socket wants a struct value, and I already prepared here for you some input files. So we have fleet and JSON. So let's open this up. Fleet, you see I created in this case 3 drivers, Mario, Luigi and Peach. This is the starting location, the coordinates. This is the name, and you see here I don't have any constraints like load or capacity, any such thing. So we're going to solve a simple routing problem basically. Copy, and we're gonna put it here as a default value to our variable fleet. Similar way we can set up the locations on, again, struct. Then I go here, take the location, copy. As you see here, I have a set of coordinates, right, where we want to deliver the items, and put it here. Paste. Very good. Now we're going to use the post-simulation event to print out the results after the simulation is finished, after the optimization process is finished. So post-simulation, and we're going to add print string block. Let's wire this up like this. And the print string, as a reminder, is going to print some information. The string that is going to get into the string value socket here is going to print it into the details panel on the main window. So what string value do we give? Well, we want to print the route component, which is going to hold the optimized routes at the end of the process. And as we saw, we want to serialize first the component, and the serialization block is going to serialize into a struct, and then we want to convert the struct into a string so we can print it out. Very good. Now how do we run the simulation process? How do we optimize our routes? Well, in that case we have to add the component that is going to be the brain of our routing system, and this component is decision maker. So if you right click here on the main window, you see that under AI I have a AI decision maker. An AI decision maker is basically another agent that cannot be dragged into the decision network, but it's going to be, let's call it an invisible agent. This decision maker is going to be the brain of our agents, in this case of our routing system agent. A decision maker owns an agent and decides basically decides what are the actions that this routing system is going to take, right? So to say that we want this AI decision maker owning this routing system, we go back to our routing system event graph, and we want to specify that our decision maker is AI decision maker, which is the only one that we created. So we double click on the AI decision maker. Now we open up another event graph window, and here in this case we can use again another event, in this case the begin simulation. All right, and what do we do when we start the simulation? Well, we are going to run a behavior tree. We saw in previous episodes that we can define how an agent behaves using a behavior tree. We can specify. So let's create a behavior tree like this, and so you see we have a routing system agent, we have a decision maker owning the routing system, and the decision maker is using a behavior tree to specify the decisions, right? How the agent behaves. So let's go back to our decision maker event graph. On begin simulation, we're going to add run behavior tree block. So wire these things up, and you see that we can select the behavior tree. In this case, we have only one, our behavior tree, and so when this is going to be triggered, it's going to run our behavior tree. Very good. So now, as we've seen, we can open up the behavior tree editor, and this is a behavior tree. And what we can do here is simply using a task optimized component. So we saw last time that the behavior tree runs top down, left to right, and we can select different options. We can specify how our agent should behave, if it wants to monitor the system or run after some waiting time or compare some variables. In this case, we simply add only one task optimized component. So this optimized component task is going to take what agent, our routing system agent, and what component, the route component. It's going to optimize the routes of our routing system agent, right? Because we already specified on pre-simulation, we specified the fleet and we specified the location. So when this is going to be triggered, it's going to optimize those two things with all the parameters that we specified. Now, you see that, just a note, this optimized component is going to call the parallel AI backend system, backend engines. It's going to send the data on the cloud. The cloud is going to compute the routes and it's going to send back the results. Now, what if you want, for example, to run your optimization engine or specify your own algorithms to optimize your fleets in the way that you're used to? Maybe you have some code that you have created for yourself and you want to use that code. Well, you can do that by creating a custom task here and specify inside the task how you want to optimize your fleet. For example, you may want to connect different optimization engines. So, for example, you want to use a mixed integer programming model combined with a genetic algorithm model and so on, right? Well, that is all things that you can do within one task, or maybe also connecting a sequence of tasks here. And it's a little bit too complex for this video. I want to just show you how you can simply run optimization as a service in it. Now, let's go ahead and start running our system. So you see that when I run here, the system is going to run the simulation, and it's going to run basically, let's go back actually and take it up. See that it runs in pre-simulation, it runs the top events here. So this event was triggered before starting simulation, and it set up all the components, the fleet and the location into our agent, into our routing agent. And in post-simulation, when the behavior tree finished, it triggered this event here, which in turn print onto the editor here the results. When in begin simulation, instead, what we see in here, we run the behavior tree, which in turn run the optimization and print it here. And now you see that these are all the results of our optimized routes, right? And you see that we have Mario, Luigi, and we have Peach. pitch is basically visiting all the locations. We have this is the distance here. It's basically running a TSP. Why Mario and Luigi are staying at home? You see that they started and they ended at the same location, which is the depot, right? They didn't go anywhere, and distance is 0. Well, because we didn't specify any constraints like time constraints or load or capacity of the vehicles, right? So the backend system thought, okay, I can do everything with one single vehicle, and I'm gonna do that all with the pitch driver. We can, of course, specify further constraints, side constraints, time windows in the event graph, but that again is for another video. So with this video, I wanted to show you how you can link all the things together. So we have a routing system agent, and then we create the decision maker, which is the brain of the routing system, and we use behavior trees to set the brain, so the AI inside the decision maker that is going to take decisions for the routing system. And you can do that for multiple agents and in different, now we only have the transportation here, but you can think about scheduling and so on. In later videos, I'm going to show you how to take all this system here, and instead of using pre and post simulation events, we are going to use events that are going to be connected to an API on the cloud, so you can send these results not on the editor here, but you can send to an endpoint that you specify, for example, to a phone or to another part of your system, to an entry point. And then also, of course, we are going to see how to deploy this system here on AWS and decide your architecture. So instead of running it basically here locally and calling the backend engine on the cloud, you run everything on the cloud, and it's gonna be there for you. Basically, you're just going to send out some API calls, and it's gonna trigger the same system, exactly the same, and send the results back to an API that you can specify. With that being said, though, that's all the time I have for this video. I hope you enjoyed, and if so, visit parallel.ai so you can ask for this pre-alpha version. You can try it yourself, you can play with it, and thanks for watching.